Hi. So we are going to see the commutation logic of a three-phase BLDC motor where the back EMF from the stator winding is trapezoidal. Here you can see that the three-phase back EMF is represented by red color, Y phase is represented by green color, and blue phase is represented by alphabet B and color blue. In a similar context, we can see that the three Hall sensor are also phase shifted by 120 degree. Here we must remember that each Hall sensor conducts for 180 degree, and for every 60 degree commutation, here we can see that any one Hall sensor changes its state. And the second point what we must remember is each phase of our stator winding conducts or it is energized for 120 degree electrical. So upon considering these two facts, what we can see that if we start from this 60 degree commutation, the logic which we are receiving from Hall sensor, the three Hall sensors are, first logic is 001. So upon seeing the back EMF, what we can see that this Y phase should have lower switch to be conducted, like here to have this Y phase negative, it S6 should conduct so that this negative DC link should be connected with this phase Y winding. And what is the next thing is we can see that the two phases like phase R and phase B are in transient, they are changing state. So here what we are assuming that the B phase top switch is conducting. Let us assume that S5 is conducting. So if we go for the next 60 degree where we are receiving logic of 101, so here we can see that phase R is positive. So we will turn on S1 switch to connect our phase R with positive DC link. So for the second phase, as we have Y negative already conducting in previous 60 degree commutation period, so we will continue that phase so that it should conduct for 120 degree electrical. And also we must remember that since each phase is conducting for 120 degree electrical, and only two phase is conducting at any instant of time or at any point of rotation. If we see next 60 degree commutation period, this one where we are receiving the logic of 100 from the three Hall sensor, it means that our B phase should be connected to negative DC link by turning on our switch S2. And here we can see that the other two phases are changing state, R phase and Y phase, and since our S1 switch is already conducting, so we should keep it conducting for the next 60 degree so that the phase R conducts for remaining 60 degree and it should conduct in total 120 degree electrical. Similarly, we can analyze other three conditions what we are receiving from our Hall sensor. Upon analyzing all these six logics, we can create our lookup table, what we can see here, which contains the information from the logic, from information from our Hall sensor, and correspondingly it should contain the information about the switches which should turn on as per the Hall sensor's output. So this is how we create our lookup table, and this lookup table can be used in our controller so that we can control our BLDC motor with 120 degree conduction mode. Thank you.